Hi everyone, today we're going to be doing bisection, which is a method used in numerical analysis for finding where the root of an equation is. Today we're going to be doing the equation, let's see here, if I can zoom in, x cubed minus 2.1. If anyone else knows off the top of their head what the root is for that, well then congrats. I mean, obviously it can be solved algebraically, but we're going to assume it can't be. We see there that it intersects somewhere between 1 and 2. Well, at least between 0 and 2, since there's markings between 0 and 2. So, I'll show you how to find the root. This is a concept I learned in a course called EE 231, which is a numerical analysis course for electrical and computer engineers. Alright, so we said that we know that our root is somewhere between 0 and 2. Now, XL is our lower value, and XU is our upper value. So we know that somewhere in the center we're going to have a root. So what we're going to do is we're going to calculate something called XR, which is X root. And we calculate this by taking our X upper, subtracting our X lower, and dividing through by 2. So that's 2 over 2, which is 1. So XR equals 1. Alright, let me just write down our formula here. X cubed minus 2.1. Alright, so now we're going to calculate f of, we're going to say f, this is equal to f of x. So now we're going to calculate f of xl, f of xr, and f of xu. Alright, so calculating f of xl minus 2.1. So that's our f of xl. F of xr is just 1 cubed minus 2.1, which is negative 1.1. And our f of xu, so it's 5.9. Alright, so the way to now picture this is we've got a graph. Here's 0, here's 2, here's 1. This is our xr in the center here at 1. We know that the function at f of xr is minus, so we're going to plot a point here down below the x-axis. And we know that at that xl at xl we've got a negative value too, so we're going to plot another point here. And then at f of xu we've got a large positive number, so we plot a number here. So we know our graph looks something like this. Alright, obviously from the graph on the computer it doesn't look quite like that, but we get the idea. So we know that the intersection is going to be somewhere between xr and x upper, or xu. So our value is going to be somewhere between the values 1 and 2. So we now adjust our x lower to be equal to our xr. And now a quick way to do this, instead of having to always draw a graph and visualize it, you always look for which has the same sign. If f of xl and f of xr have the same sign, that means your new f of xl will be f of x, or your new xl will be your new xr, or rather your old xr. So we know that our x of l is going to be equal to x of r, or xr, which is equal to 1. So xl equals 1, and x upper equals 2. So we're going to recalculate our xr. 2 minus 1 over 2 equals 1/2. I just remember now, we've got to add that to our lower value, which is equal to 3/2. So x root equals to 3/2. Alright, so now we calculate f of xl, f of xr, and f of xu. What it was before, 5.9. Alright, so hang on, that's one iteration there. That's our first iteration. This is going to be our second iteration. And So we see that these two are positive values. So now what we do is we move down our XU. So we say that our X upper is equal to XR, which is equal to, what is XR? 3 halves. So we know that our value is somewhere between 1 and 3 halves. So we know that, okay, so f of xl is still equal to negative 1.1. F of xr, we still got to get a new xr. That's an old iteration. Hang on. And f of x upper is now equal to our old f of xr, which is equal to 1.275. I just realized that I need to calculate a new xr. So our new x upper is 3 halves minus our x lower, let me find it here, which is 1, over 2 plus our x lower, 5/4, I believe. I hope I did that right. So we're going to calculate f of xr, which is f of 5/4. So let's see here, 5/4 cubed minus 2.1, this very small negative value. Negative 0.146875. So we see that f of xl and f of xr are the same value. So our new xl is equal to our old xr, which was equal to, I erased it, but 5/4. Alright? And we know that our x upper is equal to 3 halves. Alright. So, x upper minus x lower over 2 plus x lower. Alright, our new value is 1.375. Once you have done a number of iterations, you can check the accuracy of your work. And the formula for that is simply epsilon A, which is, this is the approximate error, epsilon A, which is approximate error, is equal to x root minus x lower over x root, absolute value of that times 100%. And that formula there is the one you use to calculate your error. So let's calculate our error. Our XR for this last iteration was 1.375. Then subtract off x lower, which was 5/4, over 1.375 times 100%. 9 point, I guess you could just say 0.9%. So our epsilon A, approximate error after, I don't know, 3 or 4 iterations is 9.09%. What the approximate error does is it is the error. It is the maximum amount of error that there could possibly be in your calculation.